Hi guys, so this is our video on chapter 7.6, inverse trigonometric functions, and the whole chapter is basically based around these 9 formulas. These formulas for differentiation and these are the formulas for integration. In a few seconds we'll show you how to use these formulas to solve a few questions. So, in this example, y is equal to secant inverse 2s plus 1. All we have to do is to apply the formula here for secant. So next, we have to substitute 2s plus 1 back into u once we've applied the formula. So we will get 1 over modulus 2s plus 1 multiplied by square root of 2s plus 1 squared minus 1 multiplied by 2, which is du ds. After we've done that, we have to expand 2s plus 1 squared, because that's going to cause us problems later. After expanding, plus 1 minus 1 cancels out. So after cancelling off the 1's, we have 1 over modulus 2s plus 1 multiplied by square root 4s squared plus s times 2. Next, we just have to pull out this 4 and simplify, and we get our final answer. 1 over 2s plus 1 over modulus 2s plus 1 multiplied by square root of s squared plus s. And we're done. So in the case of y equals to tan inverse log x, we'll use the tan inverse u formula because that fits the best. The first thing we have to do is to let u equal to ln over x. Next, we differentiate u, so we get 1 over x. Now we have to apply the rest of the formula, so we'll get dy over dx is equal to 1 over 1 plus u squared multiplied by du dx. Next, we sub in what we learned there, and it'll go something like 1 over 1 plus ln x squared multiplied by 1 over x. Now, simplifying that further, we'll get our final answer, which is 1 over x multiplied by modulus 1 plus ln x squared.
To solve this question, we use this formula. First of all, we take out the 4, which will give us 4 integration of 0 to 1 ds over square root of 4 minus s squared. As we know, a is equals to 2 while u is equals to s, which will then give us 4 sine inverse s over 2 and the limit 0 to 1. By substituting the value of 1 into this sine inverse s over 2 will give us 4 sine inverse 1 over 2 minus sine inverse 0, which will then give us the value of 4 to the bracket of pi over 6 minus 0, and we will get our answer 2 pi over 3. Okay, to solve this question, we will use the tangent inverse formula. First, we let u equals to x minus 1, and then we will differentiate u, which will give us dx. And as we know, a is equals to square root of 2. By applying that formula, it will give us 1 over square root of 2 tangent inverse u over square root of 2 plus c. And then we substitute x minus 1 into u, which will give us the answer 1 over square root of 2 tangent inverse x minus 1 over square root of 2 plus c.
Smile. So expanding, plus 1 minus 1 cancels out, and one go.
So by substituting So by substituting 1 into this form.
Ada yang pointing ya.